Hi, welcome. So my name is Kramer. I am the engineering lead for the Azure government platform. And so my team's responsibility is to build the platform. So we rely and work with our partners in where do we build data centers, where do we, what hardware do we put in the data centers, what services do we bring in, how do we think about identity in the government space, how do we think about networking and things like that. So we kind of look at that platform end to end and make sure that it's there, functioning and working. So Karina asked me to do this kind of year-end roundup on where we had been and where we had gone. So I figured I would first use a shameless tactic of leveraging my children. So about this time last year, I had Armando, who's a little one there in his sister's lap, and sorry, I think I'm blocking stuff. So he is just born in this picture, and so that's kind of where we start our journey for Azure Government. So when we were this time last year, we had 4 express route locations, and we had, sorry, I'm clicking through my animations too quickly. Wow, my animations are broke. Okay, so imagine here that there are 2 regions. They went by very quickly. And we have 4 express route locations. So as we close out this year, we have 4 regions now. We added 2 down there in Texas and in Arizona, and we added 2 DoD regions. So we have 6 regions now that cover the country. So this is quite a challenge to build these new regions. So you can imagine we have to start with new facility, we have to plumb in the network, we have to bring in the hardware. We're bringing in tens of millions of dollars in hardware, hundreds of racks of computers, get these all set. We then have to accredit the facility. We have to make sure that the security meets the needs that the government has laid out for these things. We have to make sure the personnel is screened by CGIS. We have to do all these things. Okay, so we brought these regions online. And we did that. But not only did we do that, we expanded our footprint to the West Coast for us to be able to have express route locations. So this means that agencies that have a footprint across the country can peer with us, both on the West Coast and on the East Coast, get on Azure's network and ride our dark fiber into the data centers where your applications are. So this is a great opportunity for us to have a nationwide footprint that enables you to run applications closer to the customers that you need to serve, and to have disaster recovery capabilities that allow you to go both East and West Coast. Okay? Cool. Okay, next one. We had pretty good compliance starting out the year, so that was good. But we added a couple of key things. There we go. We added DoD level 5. So we were the first hyperscale cloud to add DoD level 5 compliance, and we also added DFARS. So for customers building things that go boom, they can run on top of our platform and supply the DoD. Okay, these were kind of fun to build all up. So here we go. We had CGIS states, and so everybody look at that map. It's pretty good. And on this map, we went up to 30, so we got a lot more bubbles. Okay, so we added a bunch more CGIS states. This enables, if you're, as we've talked about before, building things for law enforcement and stuff like that. We have a lot of partners building for, say, police body video camera. We've had talks here at the meetup before about what that looks like and what those things are. This enables you to build solutions on top of our platform that can address most of the police departments, most of the law enforcement officers across the country. Let's get into something technical. So, as Vishwa said, probably the meetup earlier this year was like, where are the compute options? Okay, this is kind of a sparse slide that we started out with at the beginning of the year. But as we rolled forward, we both brought in a bunch, and you'll see a lot more arriving early in the next year. So we brought in capabilities for you to do big compute, high memory compute. We brought in capabilities for you to do GPU computing in the government cloud. We are bringing in high performance computing is about to go live. So if you need InfiniBand connectivity and low latency operations to be able to chain things together and do that, if you need GPU based computing to do machine learning models, to do graphic and imaging processing, we have that capability. And so these things are opening up new opportunities. And we were I was at the NVIDIA conference, the GTC conference that they had a few weeks ago, and it was super interesting to see some of the capabilities that could be done in a GPU. So we took one of our G-series VMs. This thing's got like 64 processors and half a terabyte of memory, and we were running machine learning models on it. And so all the CPUs are pegged, 100% running for that no time. We run that same thing on one GPU. The CPUs obviously are doing nothing. The model finishes in like 45 seconds. The one running on 32 procs is still running. So this opens up opportunities for you to begin bringing machine learning capabilities, intelligent applications in that can execute at a phase that's different. There are also super cool things with databases. So we've had database technology forever, but what happens when you take a database and you reimagine it to run on top of GPU and give it high-speed capabilities that it didn't have before to be able to do queries that were not possible before at a scale that wasn't possible, but using GPUs. So GPUs open up a whole bunch of things. And you know, I've had computers with a GPU in it, right? We have laptops with GPUs. Like, why was this a big deal? I was looking at the GPUs that we put in these things that we give you access to. To buy one of those cards is north of $5,000. Okay? So this is not a like buy a bunch and just drop it in my data center type operation in a lot of cases. But we have the capability now running in the cloud. You can get it, you can use it, see if it works, you see how it goes. You don't have to procure these things, you can do it. So it's a great opportunity to look at these things. Yeah, Vishwas. Yeah, I'll take questions, man. I'll repeat the questions. Check. Yeah, so we're doing two things. So we can enable the SAP HANA. That's the bare metal solution. So we will enable that for people that want to bring that. So this is just to be clear, so we announced Cray. I don't know if any of you saw that. So Microsoft can do Cray. That's basically us hosting Cray in our facilities, connecting it up to the Azure network, and giving you capabilities. So why would I want to do that? Because Crays are expensive. Well, you still have to buy the Cray, so we don't mitigate that. Any other ideas? Yeah, well, you can say, but basically, if you look at a data center, okay, this is kind of the idea. If I look at my data center, and I got a whole bunch of things in my data center, but I've got kind of Cray computing, probably central to some of the work that I do, supercomputing, basically, I can do these things. I can now bring those workloads up to the cloud, and I can have all the ancillary things around it run in the cloud, because it's directly piped in. I don't have to rewrite all of my, all of these programs that have built up over years. I can migrate them in. I can run on bare metal that is similar to what I had previously in my data center, but it's on my Azure virtual network. So when it's on my Azure virtual network, all of a sudden I can say, well, what if some of the data sat in Cosmos DB? What if I ran a batch job? What if I offloaded some of that capability to a functions app instead of necessarily having it run on the supercomputer? And so as you look at what we're doing, that's the same kind of thing we've done with SAP HANA. So we have M-Series coming early next year. And with M-Series, you can get 2 terabytes of memory and a whole lot of processors to run really large databases and really large SAP workloads. But for some people, those SAP workloads need more. And so that's where the SAP HANA, the purpose-built stuff comes in. Again, we drop a purpose-built hardware, we dedicate it to you, give it to you to run your SAP HANA workloads. So now, I can bring that really complicated SAP HANA thing and just put it in the cloud. And now I can build all sorts of fun stuff around it, okay? And I can begin migrating pieces off of it, right? I don't necessarily have to move it all at once. I've got low latency connections. I've got abilities to do all sorts of fancy stuff. So we can do those things in the cloud. And what it does is it opens up a whole range of opportunities on how to think about my migration. I'm no longer just moving a bunch of VMs that I have that really aren't that important to me. They're maybe doing a bunch of side work. I can now begin moving the central part of my business, all the VMs that support it, and then modernizing while I'm in the cloud. Okay? Questions on that? Okay. The other thing that we really addressed this year that we pushed a lot on is how do I trust the cloud? How do I know what's happening? So I used to have a firewall, and I used to have a switch, and I could like monitor that, and that was fine. But now I'm in the cloud, what telemetry am I getting? How am I thinking about this? This is a repeated conversation that we've had with a lot of people, and has been a heavy area of investment for us, because the interesting thing about the cloud is that with software-defined networking, it opens up a wide range of possibilities for me to deeply understand what's happening in my applications at all times, but not just in my application on the network, but happening soup to nuts, top to bottom on my applications. So we delivered log analytics, which is part of the OMS suite last year. We added a whole bunch of capabilities. So there's something called Network Performance Monitor. So who here has had a network problem before? Anybody? No one. Okay, I see. So network performance problems are notoriously difficult to track down. So what the team did in OMS is they built something. So when you have the OMS agent running on a machine, or you have us talking to endpoints that exist inside of Azure, you basically put it on machines, you put it on you say what endpoints you're interested in, and it begins doing lightweight pings between those endpoints and monitoring what were the hops in between, what was the latency between those hops in between, and what is it repeated. So now I can begin building a graph of my network up in the cloud, great, that tells me the latency. And with OMS, to turn it on, if you are already using OMS, I don't have to deploy any new agents. I don't have to do anything. It's a native capability that gets built in. You enable it. And all of a sudden, the data starts flowing back. The cloud does all the analysis, the correlation, the analytics, and do this. So I have seen this on-premise before. It's not that this is capability that we just invented. But what we've done is enabled it to be done easily and in a way that is baked into software that you could be using for patch management. You could be using for your security, and using for detection of vulnerabilities across the board. So I kind of give you fake capabilities that are end-to-end that enable you to both bring on-premises telemetry into the cloud, but also to monitor your cloud applications. Okay. The next one we brought forward is Network Watcher. So Network Watcher answers this question of what the heck is going on my network. So I can do packet capture in the cloud. What does that look like? What is the traffic that is traversing my VNet? What are the packet capture that is happening? What are the capabilities that I'm seeing? Where am I seeing faults? Where am I seeing problems? And so this gives you analytics into your network. And again, this is a theme that we are attempting to drive, which is top to bottom, how do I trust the cloud to know what it's doing? And for Azure Government specifically, this is super important for us as we try and enable the higher order workloads, the more important workloads. So I'm very interested in how do I get the workload that helps you catch the bad guys, that helps you drive efficiencies into the way we do finance, that helps you do these things at a higher order and things like that. The final one that we brought forward is we brought Azure Security Center. So we announced this before, and what we did first is I've brought you the most important thing. I brought you analytics first. We're bringing some UI stuff that'll make this easier in January, Feb. But right now what we have is we have the analytics that come from the power of Microsoft. So Microsoft has some of the largest internet properties that are out there. So think about Xbox Live, okay? Xbox Live is one of the largest gaming services out there. And do gamers like it when someone hacks in and dorks with their gaming scores? No. Is that important for us to maintain the integrity of something like Xbox Live to retain all of those subscribers and do those things? Hell yeah. Okay, when you look at something like our Office 365, it is a very major email platform that is used by people all over the world. It is incumbent upon us to keep it secure and protected. If you look at the stuff that is happening with, we have other mobile and internet properties that are out there, and then we also have Windows. And so when you begin looking at all this data, you have a depth of understanding of what vulnerabilities are out there, what things are happening, and how can we bake in intelligence to protect that. And so this creates what we call the security graph, which allows us to understand what are the behaviors across internet properties, across things that are happening in Office 365, across things that are happening on Windows telemetry and things like that, that enable us to understand how do we detect problems. And then we say, that's great that we understand that and can protect our networks, but how do we then bake that intelligence into a process that enables you to protect your cloud applications? Okay? So when we detect something, you now detect it, and you detect it in a way that you can remediate and drive action. And so this then begins something that I can look at my on-premises stuff, I can begin monitoring my network, I can monitor my applications at a higher level. We have begun to give you kind of an end-to-end capability to look at your stuff across the board and derive intelligence that was not previously very easy, but is now baked into the platform. Okay? We didn't stop there. We delivered, I stopped here though. I ran out of slide goodness at this point. So we delivered a bunch of stuff. So there are Cog Services, which is bringing some of our AI capabilities. That is available in Azure Government today. even just basic table stake stuff like hot, cool storage. So it's great that you can put a bunch of storage in the cloud, but how do I optimize cost around it? What if I can take the data that I don't access a lot, tell Microsoft I don't access that data a lot, and then we'll charge you a fraction of the previous price, okay? Because we'll optimize it and kind of put it over here. It'll still be accessible whenever you want it, but we'll redo the cost model, which enables us to change the way we do things. Cosmos DB, so we brought a NoSQL database that allows you to do MongoDB type operations, allows you to do Gremlin, things like this, up in the cloud running on Azure Government. If you want to build it broadly distributed, it takes about 3 clicks in the UI to have a database that's spanning Arizona, spanning Virginia, that goes down to Texas and things like that. You have those capabilities. Media analytics. So if you want to begin looking at video that you're taking and how am I indexing all the faces that I've seen, okay? So this is super interesting in the demos that we do with CNN feeds, and it can identify political characters, but creative programmers could probably make it do whatever you guys want. Okay. As you look at VNet peering, how do we enable you hyper connectivity between different virtual networks that you have as you look at creating concentric circles of networks or layers of disconnected networks that may have different capabilities and you only want to let certain traffic move between things? We can do those types of things. And one of my personal favorite, but probably the least technically savvy, is our site recovery and backup capabilities. So we've talked to so many customers, and honestly, my family comes from Florida. They had some hurricanes down there. I know people in Puerto Rico. If you look at this, we work a lot with state and local governments, though. They have to put their data centers where they can put them. And so when you look at Houston, Houston had to put data centers in Houston, and there was a tragedy in Houston. So how do we help those guys leverage the cloud to where they can have failover that goes to the cloud when they need to? And so site recovery doesn't take a PhD to set up. I don't need a ton of things. I can connect it to my existing VMware hosted environments, and I can enable failover to the cloud so that when something unexpected happens, because who really has exercised or enabled true DR capabilities? It's a very limited set. And I was meeting with a customer the other day, and we were asking, well, what is your DR plan? And everybody around the table laughed, right? They knew that it was weak. They knew that it was problematic, and no one likes that. No one wants to accept that, but it's really hard. And so with something like Azure Site Recovery, you can be sitting in a data center in Southern Virginia, and you can enable failover to the cloud. It can be configured, and what a lot of people do is they actually use that for migration. So what is a migration but a one-way failover? So it opens up all sorts of opportunities and capabilities for you as you begin looking at these things. And we've brought tons of marketplace opportunities from our third-party partners. Storage encryption as we continue to up the security and things like that. So there's a lot of services, a whole bunch more that we've done. If you've been on our blog, there's a bunch of services coming out as we drive these things, and we're continuing to build that momentum going into next year. Questions? Okay. So 2 final things. I want to talk about technical content. So one of the things that we've really tried to do is Karina and Vishwas have been doing a great job with the meetup as we do locally here. We've been streaming it online, but we've also said, how do we deliver technical content out? So we have a great set of videos that we put up that talk about how do you do identity in government? How do you think about network connectivity? What does it mean to migrate an application up to Azure? And these are focused videos on what does it mean to think about that from a government perspective and things that you guys are doing. So ak.ms/AzureGov videos will get you there, or you can go to our documentation site. We've got it linked off there. So a bunch of fun videos that are up, well, fun may be a stretch. We did them. But they're up there talking about what does it take to migrate, what does it take to do, and trying to give more contextual and a different way for you guys to think about it. Karina talked about the Hackfest, and these have been super fun to do, actually. So several of you in the room I've seen here have been at the Hackfest, and we did the in DC. But we did the first Hackfest back in June. We have since done more than 15 of them around the country. So they kind of exploded based on the participation that we had here. So we've had over 500 people come through them, lots of applications that are being built. We've actually, several cities around the country have launched interactive bots for their FAQs and things like that across the country based on things that have happened in the Hackfest. We've seen lots of other applications come out of these things. It's been really great to see. Karina had the URL up earlier, ak.ms/AzureGov Hackfest. If you want to look and sign up, or if you're out there on the live stream looking for one coming to your city, we are coming around the country and doing these things, and it's been a great way to get your hands on and then meet people in the community, because one of the things we've talked about is how do we build that together. Okay. Yeah? Okay. You don't have a point? Okay. That is our Chevy Chase office. I presume that we bought the office furniture from the same company. My favorite room is the one there on the right, which was the LA Athletic Club, which is something started in like the 1800s and was super funny to deliver a technical thing. And any of you have delivered a technical presentation, I have learned to value the podium because whoever rigged up the AV put it like way over on the side and said, oh, I can share your slides. I was like, but I gotta do technical demos. So I stand in the middle and talk a little bit, and then I'd walk way over to the side, and then I'd type, and then I'd come back, and then I'd type. It was the worst. But the room was beautiful. It made a good picture. Okay, so the Azure Gov Hackfests have been great. We're trying to focus, again, more and more content, more and more outreach for you around what government does, how we think about it from a government perspective, and how we meet you where you need to be for the things you need to deliver for your customers. Okay, so back to where we started. He turned a year like a couple weeks ago, and he can now sit up, and he's playing with his little brush, having a good time. So that's our year in review for Azure Government. Are there any other questions I can answer? Yeah?
How different is the hot and cold storage? Like, is there anything being compromised on the security or on the performance? Like, if I'm going to fetch a data in the cold storage, the turnaround time is going to be more than the hot storage.
Okay. Yeah, so what we do with hot, cool, oh, sorry. What are the differences, what compromises would you expect between hot and cool storage? So we're actually doing three things right now. So right now in government, we have hot and cool storage. So what we do, the difference between hot and cool is twofold. One is the pricing model. So when you think about hot, we charge you a certain price on storage and a certain price on transactions. What we do on cool is we kind of flip it. So we charge you more for transactions but less for storage. The idea being that you're writing, it stays there, you're good. And then the second thing is that there is a reduced SLA on read operations. And so basically what will happen is, what we typically see in applications that do cool storage is you would have, you have your traditional retry logic. So most of the time you're fine. And we've actually seen that the SLA delta is actually very small, but because of the way the model works, we kind of reserve the right that if we see certain spikes or things like that, the SLA can be reduced. And so basically for cool storage, you would retry. From a performance perspective, otherwise, it's exactly the same. Okay, so the speed of reads, the speed of writes and things like that, the capabilities and throughput are the same. There just may be some reduction in, we may throttle basically sometimes when there's high demand. That's kind of, we reserve the right to do that. Yeah, the overall SLAs are different. So it is the same basic, it's the same basic implementation, but we reserve the right to prioritize hot reads and writes over cool. Okay. There's a third thing coming, which is archival storage, which is like cold, you can think of it. And on that one, that is like Glacier inside of AWS is analogous, but it's actually moving to different physical media, which is like, and so you have more like, and that's super cheap, but your SLAs are more like, I forget what it is exactly, but it's like an hour to read or write. So it's more like you're tiering it up because you're moving it off of kind of persistent storage in the background. Okay, no problem. Other questions? Yeah, what's up? I'll repeat it.
Can you shed a little more light between Macy and I think it's called the new iteration guard duty? Is there any difference? Or will that be coming to?
Macy and guard duty. I'm not familiar with those. Difference between Macy and guard duty.
It used to be Macy, but it's now rebranded as guard duty, and I wonder if it's coming to. We could take it off.
Yeah, we'll take it offline. I'm not familiar with that one, I'll admit. Good job. I know a lot of things. Okay. No, I'm sorry. I'm happy to be stumped. I learned something new. I look at it. Okay. Other questions? Yeah.
Storage encryption.
Yeah.
Elaborate on for the certifications and so forth. Is that
Like FIPS compliance or?
FIPS and the CGIS and all that?
Oh, so from a CGIS perspective, all of our services, so we kind of basically, we get our services compliant from FedRAMP, CGIS, and all that stuff at the same time. So the the storage encryption meets those standards across the board, so we're good there. We meet the FIP standard for the encryption, and what actually happens is it's backed by Key Vault, which is what actually holds the keys, and the storage encryption is there right now. What the feature we currently have enabled in Gov is Microsoft holds the keys. On that case, we are enabling customer holds the keys, where you can basically put them in your own key vault going forward, so that should be enabled in the near short term. Okay, and that'll enable you then to be in control of the keys of when we encrypt it on disk. Okay, other questions?
Yeah, is PIM available?
PIM, privileged identity management? I mean, we have the AAD stuff, and we've released the AADP, which gives you the ability for some of that stuff, but I would have to debug kind of what specific features you're looking for there.
So as far as identity, though,
What?
As far as identity, is it pretty much the same as a commercial, or is there certain limitations?
Oh, it's pretty much the same as commercial. Yeah, the biggest one that we're working on is actually a new, for identity, the biggest one that we're working on is for a new, basically new features around Gov, which is how do we think about MFA for Gov, and enabling MFA that meets the NIST standards that FedRAMP High requires. Yeah, so that's one of the things that we've been working on to make our identity solution. So we're actually working through that, so I'd be happy to follow up with you around that one. So that's a new thing for us. Okay, cool. Thank you all.